amphibians. And he supposes that they probably could sort of walk on the bottom of the pond, walk on the bottom of the ocean, across the substrate. So if you look at the limb structure of the lungfish today, their fin form, if you will, is very different. And these animals do sort of move themselves across the bottom using their fins in a somewhat of a walking motion. So he's saying that they have some pre-adaptations, if you will, to come out on the land. It's reasonable to assume that they were air-breathing, and based upon the structure of the fossil fins and based upon the fin structure and operation in some living ancient fishes, it seems reasonable that they might have been pre-adapted to a walking motion. So basically it's all coming down to the fact that the climate is warm, you're evaporating the water, these animals then are being found in small pools. Those pools dry up, the animal has no choice but to go overland to find another pool. So the first impetus, if you will, to go onto the land was to escape the drying up of the fish's pond in order to locate another one. So that's the classic theory of Roemer. It's due to the warm, arid climate. The selection force, if you will, was because the ponds were drying up. And so the animal goes out on the land to find another one, and then presumably you get selection for animals that can spend longer and longer and longer times on land, and those are our amphibians. Okay. There's another theory, by going and going, or going and going. This is more of a competition theory. And it's not necessarily mutually exclusive with Roemer's. Both of these could have taken place. They say that the advantage for the ancient animal to come out onto the land is going to be decreased competition. They note, based on the fossil record, that fish were very diverse, very abundant in the Devonian. But on land, you only had invertebrates. These invertebrates are an underutilized resource, right? Because there are no vertebrates on the land eating them. So they speculate that actually it was the juvenile Rhippidistians that were the first to come out of the water and move onto land. Right? Why? Well, three main reasons. First, the juveniles would be small and least able to compete with the adults for food in the aquatic environment. So they're least able to compete, so maybe they're going to try to take advantage of this underutilized resource. We know from what we see in our own times, animals have a dispersal stage. Most animals have a dispersal stage. In other words, at a certain age, the animals leave where they grew up and move to a new place. This is common. Many mammals do this, for example, but many fishes have dispersal stages. It could be a larval form of a fish. This dispersal by usually juvenile animals is probably a way of decreasing competition with the parents. And so they're least able to compete. They're automatically having this dispersal stage, so that means they're ready to pick up and go and move. And juvenile fishes often congregate in shallow water, right, near the edge of a pond. Why would they do that? Big fish can't go shallow. Big fish eat little fish. So what they're suggesting, going and going, is that the juveniles are congregating in shallow water to avoid predation. They're prone to dispersal to begin with. They're right there at the edge of the pond, and there's this underutilized resource that is just inches away. And so they hypothesized that these animals briefly then came out to snatch an insect or something like that, went back in, and then we would have selection for spending more and more time on land for foraging purposes, for taking advantage of this underutilized resource, and a resource that is not being used by the parents with which they cannot compete. So we do have two major theories, but they are not mutually exclusive. Both of these could have been operating in order to drive the fishes from the water onto the land and give us amphibians. Okay. All right, well, what changes are needed? There's a lot of structural changes that would be involved in moving from the water onto the land, and I'm just going to look at a few of these, mainly at things that involve support and locomotion. Like if you're a fish, your body is supported against gravity by the water. You are buoyant. You are really floating in that water to a large degree. But once you move onto the land, you don't have that support anymore. And so you have to find a way to keep your body from being crushed. So if you don't have the proper support, for example, the weight of your own body will press down on your heart and stop it from functioning. It'll press down on your lungs. It'll press down on everything, and you'll just squash yourself. So you need to find a way to support yourself against gravity if you are to move away from the buoyant water. Well, the support is going to come from the vertebrae. Fish already have vertebrae. But we're going to modify the vertebrae in many different ways, but two main ways that give us additional support for our body when we are on land. The first of these is a simple little structure. Plural is zygapophyses. Single is zygapophysis. Physis just means growth, and zig means twin. We have twin growths. Where are these growths? Well, let's say that's a vertebrae. You're looking at it from the side, a vertebra. And what we're going to have are extensions that come off the posterior of one vertebrae and the anterior part of the next vertebrae. So here again. So each one is going to have one on the left and one on the right, in the front and then in the back. So they are twin growths. These are the zygapophyses. So what that overlap is doing is giving you more support. So if you don't have the zygapophyses, then you could see the shifting of your vertebrae here, being pulled by gravity. But by overlapping, we're getting a stronger structural support. The other thing is that we add an arch to the backbone. Now this arch is not tremendously well developed in the early amphibians, even current day amphibians. It's much better developed in something like a mammal. You can look at those couple skeletons over there on the counter and you can see a really, really definite arch in there. You know, and go back to your world history class. The arch was a wonderful invention for architecture and building buildings, right? Because it added a way of giving structural support. Well, the backbone in animals is the same way. We put it into an arch-like structure, and that is going to give us more support against the pull of gravity. And in essence, we hang the body We're hanging the body from our backbone. And that's how we're keeping it from being crushed. All right, so we've got arch, we've got zygapophyses. Going along with the idea of support in locomotion, is we develop more complex girdles. So you're going to have a pectoral girdle and a pelvic girdle. These are the bony structures to which the appendages attach. So the front appendages attach to the pectoral girdle, the hind appendages attach to the pelvic girdle. These girdles will structurally support the limbs, but they also give you places where muscles can attach that will move the limbs. In fish, these things are exceedingly simple in structure, and they're usually just a slight simple piece of bone or cartilage that's embedded in the ventral surface of the animal. At least the pelvic is that simple. In the vertebrates, land-dwelling vertebrates, we are going to make this much more complex. So again, we'll look at the pelvic first. The hind in a fish is just a simple element in the ventral body wall to which the pelvic fins attach. But in our terrestrial vertebrates, it's a very constant theme of how it is structured, whether you're an amphibian or a mammal. Broadly speaking, it looks something like this. So we have a vertebra right there. It's called the sacral vertebra. The vertebra that contributes to the pelvic girdle by definition is the sacral vertebra. The number of sacral vertebrae that are used with the pelvic girdle just depends on the group of mammals, but they're all going to use them to help support these hind limbs. Coming out, we have processes coming out. We may incorporate a rib into this structure up here. But then we have three main bony elements. So the ilium, the ischium, and the pubis. This is diagrammatic, so I'm simplifying things a little bit. But what are we getting here? We're getting a bony box around the inner guts of the animal. So that if we add our appendages, that animal standing or walking, the forces are going to be directed around the innards to the vertebral column for support. So when that animal steps, its whole weight is not pushing its leg into its intestines. Instead, those forces are directed around the soft tissue to that hard, bony vertebral column that is going to support the animal. Pectoral girdle in fishes is a little more complex than is the pelvic, but it also attaches to the skull. So a fish cannot move its head independent of its body. Its pectoral girdle is attached to its head. I'll show you a diagram in a minute here. And that's probably important in stabilizing the head against that lateral component that is unnecessary